Welcome to Train Signal. You're watching a lesson on network devices. Now in this lesson, we're going to go through a series of devices that relate to networking, some of which you'll find in everyday networking and some you just might come across occasionally. But either way, you're going to have to know how each of these devices function. Now the first couple devices that I want to go over with you have to do with getting computers attached to a network, or give them the ability to communicate out onto a network. Okay, so the first one is a modem. And the first thing I will tell you about the word modem, it stands for modulate and demodulate. Now I don't want you to worry about that too much. Okay, it has to do with switching between analog and digital signals, because what a modem does is it gets your computer, which functions with digital communication, communicating over analog phone lines. Okay, so real simple, what does a modem do? It allows your computer to communicate with a network over analog phone lines. Now the other thing I will tell you about a modem before we move on is that this is a perfect example of something that you really don't see too much anymore in today's networks. The way most computers do get connected in today's networks would be with a NIC, or a network interface card. Okay, and this is real simple. It's a card that is in the computer, and when I say in the computer, I will tell you that it could be a chip on the motherboard, it could be an actual expansion card in the computer itself, or we could even be talking about a wireless NIC, where it gives you connection to the airwaves. But either way, it is just what it sounds like. It's a network interface card. It's the interface from the computer to the network. Now, the next couple of devices that I want to go over with you really have to do with the beginning stages of truly forming a network. Now, the first of these two devices that I want to go over with you is called a repeater. Now, a repeater is a very simplistic device, and it is simply used to help deal with attenuation issues. Okay, now to review quickly what we mean by attenuation, I know we've talked about it in other lessons, but that is the concept of a signal as it's traveling can only go so far before it starts to deteriorate. So you may have a situation where you can have a computer over here and a computer over here, and although my hands aren't that far apart, this may be too far for the signal to get all the way from point A to point B. So what we do is we put a repeater in the middle to go ahead and basically take the one signal in on one side, and whatever it hears, it just retransmits right out the other side. Now we're going to take a look at exactly how this works with an illustration in just a moment. But before I go there, let me talk to you about the second device, which is a hub. And the reason I want to put these two devices together is because a hub is basically, just to put it in real simplistic definition, it's a multi-port repeater. A hub is going to take the signal in on one port, right, wherever one computer is transmitting, and then it's going to go ahead and forward it out to many other ports. So like I said before, let me go ahead and see if I can illustrate to help explain how these truly function. So to illustrate how a repeater works, the idea here is, let's say we had two computers, and in order to get the data from one computer to another, you would have to travel a distance longer than the cable could handle, meaning you would suffer attenuation. The signal would die before it got to the other computer. Well, what we do is we put a repeater in between the two computers, and the first computer will go ahead and send that data, and as long as the repeater is within a distance that is acceptable before suffering from attenuation, that repeater will take in the signal, and it will then do just what it sounds like. It repeats it, meaning it retransmits that signal out towards the other computer. And again, as long as that second computer is close enough that it can receive this signal before it attenuates from the repeater, we're good to go. And I will tell you that in some instances, you may have to use multiple repeaters, right? Where you have one computer who transmits, that transmission can only make it to a repeater who retransmits, it can only make it to another repeater, retransmits, and so on and so forth until you've made it all the way to the other computer. Well, a hub is basically a multi-port repeater. The only difference between a hub and a repeater is that the hub is going to receive a signal from one computer, and then it's going to retransmit that signal out to all the other computers that are connected to it. Meaning it's going to go out all the other ports on the hub. Now, the one difference that I will tell you is the use, meaning how a repeater is used versus how a hub is used is very different. A repeater is typically used because you have a distance issue. Now, whereas a hub could be used because of distance issues, it typically is not. It typically is used to form more of your star topology type configuration. In other words, you want to have all these different computers all connecting into this central device. That's why a hub is typically used, even though from a functionality standpoint, it's the same as a repeater. Now, one other piece of information I want to make sure that you are clear on with these two devices, a repeater and a hub, is that they function at the physical layer of the OSI model. Okay, now this was mentioned in the OSI model lesson, but I just want to review that with you here. And the reason I mention that information is because it will help you to understand some of the logic behind what these devices do. Okay, because they are down at the physical layer, it means they have no real intelligence. They only know how to take in a signal and then just retransmit it out. Whereas if we move on to a couple other devices I have here, a bridge and a switch, these function at the data link layer of the OSI model. Okay, and so what that means is there's a little bit more functionality. If we start off by looking at a bridge and seeing how it functions, the idea behind a bridge is that it will be used to connect two different networks. Now, I want to be real cautious in my description here and any diagram that we'll use to look at this, because when I say different networks, we could also talk about a router separating different networks. And we'll look at a router in more detail in just a moment, but let's talk about the functionality aspect of how a bridge separates these networks. Okay, a bridge has a very simplistic routing table, which is based on MAC addresses. Now, MAC stands for Media Access Control, which we learned in the OSI model lesson is a sublayer, right? Media Access Control is a sublayer to the data link layer. Okay, that's how this all ties in. These bridges will separate these networks, but based only on MAC address, not on IP address. We'll get to that in a minute. That's where the routers come into play. Now, bridges are considered to be used to create separate collision domains. And what that means is, if we look at a diagram here, we see that there's a bridge in the middle, and then we have a set of computers on either side. Well, when a computer transmits information, when it transmits it out onto the network, that information travels along the entire network. So if we look at the computers on the left, one computer transmits, it goes out to all other systems that are connected on that network, including the bridge. What the bridge will do is the bridge will look to see if the MAC address of the destination computer is also on the left-hand side, which means it doesn't need to do anything with that data. It just kills it there. Or if it's meant for a computer on the right-hand side, at which point it will transmit it out to the network on the right-hand side. But guess what? Once it transmits it out to the network on the right-hand side, it's going to go to all computers on the right-hand side. And that's why we talk about these being collision domains. Because remember, collisions can happen when you have multiple computers communicating on the same network. The other point of interest here is that if a bridge gets a packet of information that is destined for a MAC address that it does not know about, meaning if it's unsure, if it doesn't know what to do with it, it transmits it. It just sends it out to any and all networks that it's connected to. And that's why we don't say that a bridge creates separate broadcast domains. And that's because if a broadcast were to take place, that broadcast would get to the bridge, the bridge doesn't know a specific MAC address to send it to, so it goes ahead and sends it to all networks that it's connected to. And that means that a broadcast is still going to go everywhere if the bridge is in place. Now, before we get to talking about routers, which actually do all these things that I say a bridge cannot, let's talk real quick about something called a switch, especially since switches are much more commonplace than bridges in today's network. As a matter of fact, switches have pretty much taken the place of hubs. A switch is basically a multi-port bridge, meaning a switch is built like a hub in the sense that you typically will have one computer connected to each port. But it's got the functionality of a bridge in the sense that it knows what MAC address is associated to the computer that's connected to each port. And that way, when a computer transmits and it goes into that one port on a switch, the switch will then, instead of like a hub where it sends it out to all other computers that are connected to all the other ports, it sends it only to the computer that has the MAC address that it's destined for. Now with a switch, again, if there's a broadcast, it's going to send it out all ports. Or if for some reason it receives a transmission and it doesn't know who the destination address, it says, I don't know what this is, I don't recognize it. Again, it's going to send it out all ports, and it'll go out to all systems that it's connected to. So again, bridges and switches function at the data link layer because they can only route information based upon MAC address. If we move up a layer in the OSI model, we can talk about routers. Okay? A router is a device that functions at the network layer, and therefore it truly connects different networks together. This is where most people don't consider bridges to be connecting separate networks. Okay? It just helps with some of the collisions. A router truly segments networks from one another. They have very sophisticated routing tables which can determine the best route to get information from one network to another. As a matter of fact, I don't want to go too overboard with routers here because we have an entire lesson on how routing actually works. I just want you to know and to remember that routers function at the network layer of the OSI model and that they are used to create separate broadcast domains, and that's because, unlike a bridge, who, when it receives an unknown, it just says, well, I don't know what to do with this, so I'm just going to send it everywhere. A router will only pass a packet of information if it knows where to send it to. If it doesn't know specifically where to send it to, it doesn't send it. Therefore, if a broadcast was to take place on a network, that broadcast is going to transmit throughout the network. It's going to go to all systems on the network, including the router, but the router will kill the broadcast at that point. It will not pass it along to any other networks that is connected to. Okay, so a router works with IP addresses, which means it can do very sophisticated routing functionality and is truly used to create separate networks. Beyond that, stay tuned for the routing lesson where I go into much more detail about how this all works. So before we go any further, I want to talk to you in a little bit more detail about switches. Okay, now I know we already went over the literal functionality of what a switch is by definition, but I will tell you that now in today's networks, it gets a little bit more complicated because there's many different types of switches out there. So the first thing that I want to talk to you about is something called a multi-layer switch. Now, I mentioned that a switch functions at the data link layer of the OSI model, and it does. But people, and when I say people, I'm talking about different manufacturers of network devices, they have started to get a little bit creative. And they have created switches that go beyond just that basic data link layer functionality. They have built in additional higher layer functionality. So one, for instance, is I know of switches that are considered to be layer 3 switches. So if you're out there and you're going to buy a switch and you see something labeled as a layer 3 switch, well, what is layer 3? That's the network layer. that means you now have a switch that can function based off of IP addresses, not just MAC addresses. So keep in mind that that term switch is now being used much more generically. Now, along those same lines, I can tell you that there's something called a content switch. And this is another example of a multi-layer switch. A content switch actually is functioning at much higher layers of the OSI model because it has the ability to actually go through and examine the content and filter, well, in two different fashions. There's one version where it can filter things that do and don't get through. And then there's also a version where it can send, some data that has come in out a certain port based upon what type of content it is. So again, just keep in mind that you need to know what a switch is by definition, but we also have these varieties that are out there being created by the different network device manufacturers. So when we talk about how there are different types of switches and therefore different types of functionality, where I gave you the proper definition of a switch, where it only can function at the data link layer. But in today's world, that term switch has become much more generic, and there is all this extra functionality. Well, some of that comes into play here, and I want to go through a number of different advanced functions. One function is power over Ethernet, PoE, and this is used to transfer electrical power along with data over your standard twisted pair cable. Okay, so you have switches out there that can now not just provide data communications, but it can provide power. So there are certain low power devices that you won't have to find an actual electrical source. You just plug in the Ethernet cable and connect the other end of that Ethernet cable to a switch, and that device will be powered by that. This is something that is very cool because when you take certain things, and I'm going to give you one example that I know I use here at Train Signal. We have wireless networks set up in our office, and some of those wireless access points we want to have positioned up in a hidden location, right? You don't want to see them laying all around the office, so I might want to put them, let's say, in the drop ceiling where they're hidden away. Think about it. How often do you see an actual power outlet up inside the drop ceiling? Now, yeah, you can hire an electrician and you can have an outlet put in. I mean, there's electricity up there, right? We have the lights in the ceiling. But how often do you actually see the outlets up there? And even when you do, how often are they right where you want them? They're not. So these wireless access points are actually being powered through an Ethernet cable plugged into a special switch that can do that. Now we also have something called the spanning tree algorithm, or STA, and this is used by switches to determine the best route when there is more than one connection to a node. So here's the deal. I talked about bridges and switches, and we talked about how there's not very sophisticated routing functionality. Well, in an effort to make it a little bit more sophisticated, we use this thing called the spanning tree algorithm to help us out when there is more than one way to get from point A to point Z. And those ways are being traveled through switches. And then we have virtual LANs, or VLANs. This is something that is extremely common in today's world, and it's the idea of emulating multiple broadcast domains, but by using switches. Okay, remember, I said that switches and bridges only create collision domains. VLANs, or virtual LANs, are a way of creating what seems like multiple separate physical networks or broadcast domains like you would with a router, but using switches, very often using multi-layer switches. And again, it's being done in a virtual way as opposed to a physical way. We have something called trunking, which is when a switch presents more than one VLAN configuration over a single connection over to another switch or possibly onto a router. Okay, so trunking is taking these multiple VLAN configurations and trunking them together into a single connection. There's something called port mirroring, which is where a copy of network data can be sent to a second mirrored connection, and this is done typically for the purposes of monitoring, right? So you have a lot of data and it's all being transmitted in one direction. You could send it to another connection so that you can monitor all those transmissions and see where you may have a problem. And then finally, we have something called port authentication, which is used to restrict access based upon certain authentication information. I will not go into any more detail other than to tell you that it is typically used in your 802.1x network configurations. So if we move along, the next device that I want to talk to you about is something called a firewall. A firewall is used to protect private internal networks from external intrusion. Firewalls are used to control what data is allowed in or out of a network. Now, I don't want you to get too hung up on what exactly a firewall looks like. Matter of fact, as I mentioned before, I don't want you getting too hung up on what any of these devices physically look like because they come in many different shapes and sizes. Firewalls, not only do they come in different shapes and sizes, but it can also not only be hardware devices, but it can also be a software device. Meaning your firewall could literally just be a computer with some firewall software on it. Now, technically, you're going to have some requirements in order to make that work. For instance, the computer will most likely need to have at least 2 network cards, right? One connected to the internal network, one connected to the external network. All right, so something else you want to keep in mind is that firewalls don't look like any one particular thing, but the idea behind it is that you can open and close ports, right? We talked a lot about ports in the TCP/IP protocols lesson, and that's one of the reasons that you needed to be familiar with those ports, is because if you're going to use a certain protocol and that protocol needs to travel through a firewall, well, then you have to know to have that port open. Whereas maybe there's certain protocols you don't want coming into your network, well, then you want to make sure those ports are closed. So now the next device that I want to talk to you about is something called a proxy server. Now, the first thing I'm going to tell you about proxy server, and I know I've kind of mentioned this about other devices as well, but there is no physical device. I mean, I'd be surprised if you could go to the computer networking store and say, I want to buy that proxy server off the shelf. A proxy server is more about functionality than the actual literal device. So a proxy server could be services on a computer, or it could be a service built into an individual device, you know, like even just your simple DSL or cable modem router and things like that. But let's talk about what a proxy server actually is. And I will tell you that its whole purpose in life, well, really, there are 3 main purposes that you need to focus on, not just one. Okay, there's 3 main purposes to a proxy server. The first one is that it's a NAT server. Okay, NAT being network address translation. And we've talked about this in previous lessons, but the idea behind this is that it will disguise an end user's actual identity. And to be more specific, it allows your internal end users to have private IP addresses, right, ones that are not valid on the internet, and it will perform that address translation out to a public IP address to get your users out onto the internet. Okay, so that's purpose number 1. The second purpose is that it can cache requests to save on bandwidth. All right, so the idea is, let's just say we had 2 clients here, right? We got client 1 and we got client 2. Client 1 makes a request for a certain website. Well, when it does that, the NAT server, right, we already learned that what the NAT server does is it takes in that request and caches it so that when it does that translation, sends the request out onto the internet, and then that request gets a response back. It knows the client that was originally asking for it. Well, we take that a step further now, and we, even after sending it back to the client, we hold on and cache that information so that when client 2 over here requests the same website, it goes to the NAT server, or again, it's a proxy server in this case. It goes out to that proxy server, and the proxy server says, oh, you know what? I've recently already satisfied that request. I already have that information here. I'll just send it right back to you. Now, there's all kinds of rules surrounding how long the proxy server can hold on to that information, right? Because certain websites are constantly changing. But when you have websites with static information, this can come in real handy to save on internet bandwidth. Now, the third purpose to a proxy server is that you can use it to control content which is permitted to be requested from the internet. So if you're in a business environment and you want to prevent your users from going out and looking at non-business information out on the internet, right? Maybe you have employees who, every Monday, after, during football season, want to go out there and look at all the football scores, and you're thinking, well, no, you shouldn't be doing that on company time. You can use a proxy server to deny requests out to those sports-related websites. So just to review, a proxy server has three main purposes, and you have to know what they are. Number one is a NAT server. Number two is they will cache requests to save on internet bandwidth. And number three is for content filtering so that you can control what internet sites your users are allowed to get to. Now, another device that I actually mentioned just a few moments ago is something called a wireless access point, or a WAP. And this is basically the same thing as a hub. Okay, so if we jump all the way back to the beginning of this lesson where we talked about a hub, a wireless access point is a lot like a hub, but the connections, instead of them coming in through all these different cables, they all come in via the airwaves. Okay, so the idea is that a wireless access point allows you to have wireless clients connecting to your network. Okay, and I had mentioned that in our network, we use our wireless access points using power over Ethernet connectivity to a switch so that we can have them hidden where people can't see them and not worry about tying in an outlet, or I should say a power outlet. Now, this is yet again another one of those opportunities where I'm going to mention the DHCP server, but because we have an entire lesson on it, not going to go into all the detail. But the generic idea here is you need to understand that technically a DHCP server is a network device, and this device is used for managing a pool of IP addresses which will dynamically be assigned out to your clients. The only point that I will make here is that although the term server is used, people like to think of DHCP servers as being actual computers, when in some cases they can truly be a network device. One of the most typical would be your SOHO, small office, home office, wireless router, or we could say like cable modem or DSL router that you would use at home. Very often those are also DHCP servers. Another device that I'm just going to kind of go over real basically with you here is a DNS server. I mentioned in previous lessons, and I will go into a lot more detail in the actual DNS lesson, but I talked about DNS being a naming convention, but also a way of resolving names to IP addresses. Well, the DNS server is the device that is going to do that resolution. Okay, and you'll notice I actually say here DNS is a TCP/IP service which is used. So the DNS server is going to be the device that's going to be running that service. A CSU/DSU, it officially stands for a Channel Service Unit Data Service Unit. That's kind of a long name to describe a hardware device which converts data frames used on a LAN into data frames used on a WAN. Or I suppose we could say data frames on a WAN converted to data frames used on a LAN, meaning it converts back and forth between them. Where you most typically see a CSU/DSU is when you have a T1 line, or it could be more, it could be like a T3 line, but if you have a T1 line connected to a local network, the way this works is with a CSU/DSU. As a matter of fact, let me go ahead and take you in for a quick look at a server room where one of these CSU/DSUs actually exist. Okay, so here we are in a server room, and server rooms come in all different shapes and sizes, but in this particular one, before we even look at a CSU/DSU, which is what we were just talking about, I'd like to show you just a few other things that we've talked about in this course and even in this lesson. So if you take a look up here, right at the top here, you'll notice, well, even before that, here's a whole bunch of Cat5 Ethernet cable. There is something significant about that we're going to talk about in just a moment, but there's kind of a whole mess of it here, and believe it or not, this is one of the cleaner messes that I've seen in a server room. You'll notice that up top here, they're all coming out of a patch panel, which is something that we talked about in another lesson. Coming down a little bit, right here we have a couple of switches, and to be more specific, even though they might look pretty much identical to you just with the naked eye, I happen to know that one of these is a layer 2 switch, which is more of your standard switch, and another one is a layer 3 switch, so it can perform a little bit of that networking functionality. And again, there's a lot of stuff if we were to continue through, but I just wanted to point this stuff out to you. Now, I mentioned the Cat5 cable. And the significance of this Cat5 cable is, well, that's how everything is on this network. Internally, we're all on a standard Ethernet network using Ethernet cable. So if you want to follow me back over here, I just want to point out there's a box back here on the wall. Okay, and because it's mounted on the wall, it's kind of buried here in the corner. I can't go into a whole lot of detail, but what I'll tell you is that this right here is a CSU-DSU. And the reason there is a CSU-DSU here is because there is a T1 line coming into this particular office. And with that T1 line, well, that means we have that carrier's digital line coming in. That's not going to match with all the Cat5 cable that we were just looking at. So this box, although it just looks like a white box, well, it's serving a very significant purpose. It's converting that digital line from the carrier into standard Ethernet connectivity so that the rest of our network has the ability to make that connection. So again, I know this might look a little jumbled and almost confusing, and in some people's cases, they'll say they find it to be intimidating. Well, don't let it be, because believe it or not, if you break it down component by component, it's actually quite simple. Okay, and that's the idea behind this lesson. If you understand each device and you understand what it does, then you can look at some of the stuff that we have going on here, and it'll end up making sense to you. Now we have a few more devices that I just want to quickly go through here, and we'll wrap up this lesson. The first one is a media converter. Now I have a picture of one on the screen, but I don't want you necessarily worrying about what it looks like, just like with many of the other things that we've talked about. The idea behind it is that it is used to convert between one form of media and another. And the most typical use in today's networks is where you will convert between twisted pair copper cabling and fiber optic cabling. So the media converter I have illustrated on the screen shows that there is a port for a 10100 Ethernet cable versus a 100 megabit fiber optic cable. If you haven't guessed, this is actually a pretty old device that I have on the screen, but I just wanted to show you an example where if you have a fiber network and you have a twisted pair network and you need them to be able to talk to one another, well, here you go. Use a media converter. A load balancer is something that is used when there is more than one line of communication available. Load balancers divide communication evenly between the different communication lines. So it is just what it sounds like. It's used when you have more than one form of connectivity and you want to distribute the load between them. Now, a bandwidth shaper is very similar to a load balancer in the sense that they're used to help make communication more efficient, but the difference is that the bandwidth shaper is going to give you a much higher level of control over what data gets sent where and when. In other words, if you have more than one way to transmit the data, as far as the line of communication, the bandwidth shaper, instead of just balancing the load, you can weigh the load. You can actually say, I want X% of the data to go this way, and I want the remaining data to go a different way. Okay, so the idea is the same as the load balancer, but you have better control over how much data goes over which connection. Okay, well that brings us to the end of this lesson, and I hope you had some fun learning about all the various network devices. And again, remember, some of these you're going to see every day, and others you might just see occasionally. Or some, like that modem way back in the beginning, maybe from this point forward, you'll never see it all. But either way, you have to understand how all these network devices work. So that's all I have for you. I'll see you in the next lesson.